Okay, this lesson is called Transformations of Cubics and Quartics. Hopefully those words, transformations, is very familiar word. Hopefully that's very familiar. And cubic and quartic is like, I sort of know what you mean by cubics and quartics. So that'll be the main thing I have to teach is what's a cubic and what's a quartic. Here we go. Haven't we seen this before? Up to this point, you have transformed the graphs of many base functions, such as the following. All these guys from Unit 1. Do you remember all those? Don't worry, you don't have to remember all those this chapter. If they've slipped out of your brain, we don't actually need those. The only transformations we're going to do is on cubics and quartics. Y equals x cubed and y equals x to the fourth are the only ones we'll have to worry about. You're like, I don't know what those graphs are. Okay, well, let's go back and make sure we know what those graphs are. Let's do that first. And I go back to this, which I said, you can actually pretty quickly, if you ever get stuck and you're like, I don't know what y equals x cubed looks like, you can pretty quickly go, okay, x, y, plug in a few x values, and find out what x cubed looks like. Hopefully by the time I'm done, you're like, oh, now I'll know what x cubed looks like from here on in. But if you're ever stuck, you got this. So you cube all these, and you get negative 27, negative 8, negative 1, 0, 1, 8, 27. I've done it a million times, so of course I can do it fast. But you'll just plug the numbers in and cube them all. And so let me graph these points. Negative 3, negative 27. Well, that goes off my graph, but it's still important information, so I know, head off the graph there. Negative 2, negative 8, right about there. Negative 1, negative 1. 0, 0. 1, 1. 2, 8. And then off the page. You see how this is the same on either side? We call that odd. It's the same on either side, except it's gone from positive to negative. And that's odd comes from the degree. That's where that name comes from, is it's odd degree, so it looks like this. So when I graph this thing, it sort of looks like a parabola taken off really fast on this side. And on the other side, it sort of looks like a parabola taken off, but the other way. See, it goes like that. It's got that bend that we talked about in the previous lesson. This is where the bend comes from, the cubic nature of it. Then you got your beautiful points, and you could take it and you could do all your transformations. You guys are pretty good at this. So some of you use the table, some of you use the graph. However way you do it, here you'll just have some new practice on that. What's the other one? Y to the power 4? Same thing. X this thing looks just like a parabola. It's not actually technically a parabola. You never really get in trouble for calling it a parabola, but it goes like whoomba. It just takes off like that. And we call this even, because it's even degree, but you see it just takes off like that. It reminds you of just like a parabola. It just takes off faster, that's all. So that's the basic cubic and basic quartic functions. And if you're ever stuck, you just quickly make a table of values and get the points you need to graph it, okay? There, that's half the lesson. Actually, that's most of the lesson. If you remember being pretty good at transformations, I've shown you all you need to know. We're going to transform those two functions, cubic and quartic. How do you think they'll differ? How do you think the transformations will differ? Not at all. Same type of transformations. A couple of examples. Describe the transformations that must be done applied to y equals x cubed to graph this function. Now, just a reminder, you got to watch out for that common factor. You see the x isn't by itself here? So I got to common factor out a half. Which is weird because common factoring out a half out of 1, you got to go 1 divided by a half, or you got to go, okay, what do I put in the brackets so that when I go 1/2 times that, I end up with, just let me write this in here, because I don't do it like that. Some people might divide. That's not the way I handle it. I just look at it and go, okay, common factor out the 1/2, and then I go, what has to go here? So I go 1/2 times something, and I got to end up with 1/2 x. Oh, I need an x there, because 1/2 times x is 1/2 x. And then I go, what has to go in the bracket? So I go 1/2 times something and get 1. Half of something is 1. What's the something? 2. Some people don't like that. Now, I don't have to think it out. Tell me how to get that number. How do you get that number? You go 1 divided by 1/2 equals 2. That's how you get the number. You take the 1 that's there and you divide it by whatever common factor you're pulling out. So whichever way works for you. Just a reminder, you have to do those common factoring before you can do the transformations. And now the transformations. Does this all ring a bell now? Vertical reflection. There. The negative up front. Vertical reflection. Seeing some nodding. Like, okay, yeah, I might have to brush up on this, but yeah, I'm with you. Vertical stretch factor 3. There it is out there. Horizontal stretch factor 2. That's a 1/2. You'd think that would be a compression, but it's not. It's a stretch of factor 2. And then the left 2, down 3. Is this all ringing a bell? I know the common factoring with the fraction's weird, so sort of watch out for that. I don't normally on this test beat you up with fractions, so I haven't normally selected fractions, but in the homework, try and deal with the fractions when they come along. So when you went to graph it, I just want to show you the graph. If you have your own procedure with table values, that's fine. I just want to show you all those transformations at one time, so if they haven't really clicked in for you, you can see this. So there's the y equals x cubed. You build the table values to get your y equals x cubed, and then there's the vertical reflection. Whoop! Yeah, it's been flipped this way. Then vertical stretch factor 3. Here, watch. It actually shows you in this. Watch it, vertically stretch factor 3. You're like, that actually looked like a horizontal compression to me. And that's what it'll look like. Think about an elastic band for a second. There's two transformations that sort of look the same when you do them. So take a look at that elastic band here. And I'm just going to grab it. I'm just going to let it sit there like that. And what I'm going to do is I'm going to stretch it upwards. Well, watch what happens horizontally when I stretch it upwards. You see how it thins out? It's sort of a side effect of that. If you go vertical stretch, you actually, it sort of looks like a horizontal compression that's going on at the same time. So don't be surprised if that's what your brain sees when I do that. Okay, so let's go back to that. There was the flipped graph, and then I stretched it vertically. By the way, if you're a table values person, you don't see any of this. The table values takes care of all this when you do it with the table values. It just gives you the final points. I just wanted you to see one more time, see the transformations. Then horizontal stretch factor 2. See, it's been stretched out by factor 2 there. And then what? Left 2. Here, watch. You get to watch the left 2 here. Watch it go left 2. You ready? Watching? Left 2. Yeah. And then down 3. If you're a table values person, you won't do any of that. What you'll do is you'll have a table of values for this original function. You'll do your work on it, and then you'll draw your points, and you'll get this thing right here when you draw your points. Yeah, so you'll jump all the way to the end. And I think at least over half of you are using table of values to do these things, yes? There's the final graph. Do you have questions about transformations? It was pretty good on the test. You know, like you did that absolute value one on the first page. It's like 90% right. And even someone who didn't get it right was just, they forgot to move it over a little bit. They forgot to do the common factoring. You may want to combine several transformations. You may use a table of values to do that. And the only other question that can come up would be solving for x-intercepts for these type of functions, which in the last lesson I sort of implied you had to have it in factored form, and that's not true. If it's in transformed form, we can actually do the work to get x-intercepts. All we do is set y equal to 0, and then you can just isolate x. If there's only one occurrence of x, you don't need any fancy factoring or anything like that. You can just actually solve for x. How do we do that? Well, take the negative 48, move it over, and it makes it positive 48. Take the 3, divide by 3. You get 16. And then big moment here. 4th root of 16. Your calculator can do 4th root of 16. But you can also do it in your head, because it's like 2 times 2 times 2 times 2 times 2. But if you look on your calculator, especially if you got one of the new Casio things, it's got a 4th root button on it. So you can do 4th root of 16. But the plus minus there, a couple of people missed that in the last test. When you do even roots, you got to do the plus minus. So annoying, probably, right? Probably said my name with a swear word after it when you saw that it was supposed to be plus minus. You're like, oh, plus minus. But it's an important thing, and we didn't do a very good job of really pounding that in previous grades, that you need the plus minus. All comes from the quadratic formula as well. And so 4th root of 16 is 2, and then I move the 6 over, and I get my 2 different answers here. So that's just a side effect of this lesson, is that we're able to get x-intercepts of Quartics. What questions do you have about finding x-intercepts? The real important step is right there, where I set y equal to 0. The rest of it is just solving for x with a weird power of 4 there, so you got to find out the 4th root button on your calculator. Questions? As promised, pretty straightforward, but you should practice it a little bit just to make sure you're ready for transformations. Question? No? Odd powers, you don't have to worry about that because you don't get two different answers out of that. Like, maybe that needs a little more explanation. Let's just beat that to death. Let's just make sure we have this down pat, this even power versus odd power thing. And also explain why it comes up that why you're thinking, like, why hasn't this come up before? Like, why haven't we been talking about this? The first time you run into squared is in the Pythagorean theorem, and you end up with something like this. X squared equals 25. And if we were really going to solve that equation, we'd go, what number can you square to get 25? And everybody go, x equals 5. And it's a great answer when you're doing the Pythagorean theorem because 5 is the answer in the Pythagorean theorem. But there's another number you can square to get 25. What's the other number? -5. So actually, when you do undo squaring, we should do plus or minus root 25, and there's two numbers. And so that's why it never came up when we first saw squared, because we were always doing the Pythagorean theorem. That's when it first came up. And if you said, oh, the hypotenuse is -5, everybody go like, no, that's not a thing, -5 hypotenuse. So we just ignored it. We just left it on the shelf. To your pain, to your agony right now that we ignored it in grade 9. But you had enough problems going on in grade 9, so we sort of left it on the shelf. Then later on we find out, oh, when you're actually solving quadratics and so on, these two numbers might matter. We got to do both of them. Now, why does it not matter for cubed? Or for any odd power. If we do cube root of 8, we get the first answer 2. Does -2 work here with cube? No, -2 doesn't work here. So for odd powers, it doesn't come up. It's only for those even powers that we got to do the plus minus thing. And it has to do with the graph too. Plus minus, because there's two sides. There's two answers to every question, unlike odd where there isn't two answers to every question. Yeah. Did that hit it? Yeah, good. Back to the PowerPoint. Other questions in that last example? So you got to do both. You got to do -6 plus 2 and then -6 minus 2 to get the 2x intercepts there. Because it has 2x intercepts. An odd function won't have the 2x intercepts.